Hello everyone, Eti-san. I'm Josh from the water team, or Josh and the Mermaids, and I would like to say Akwaba in joining us on our trip to Ghana this past December. As a team of engineers, we are primarily interested in bringing a sustainable project to the Afenso North District in the Ashanti region of Ghana. A few months before our trip, our Professor Roger and Joe Campbell joined the Afenso North District Assembly, otherwise known as ONDA, the governing body of the region we visited, and they assessed some of the major needs of the people living there. While visiting Ghana, you will encounter very happy, friendly, full of energy, and extremely welcoming people. Although you will see that many of the people there lack access to some of the most basic needs that many of us take for granted here in the U.S., such as clean water for drinking. In this region of Ghana, people often drink water from wells or even open springs where treated water is not widely affordable. It's been found by previous trips to the region by Ghana for Sustainable Change that many of the water sources they drink are contaminated with bacteria including E. coli and also harmful nitrates and sediment. The goal of our visit was to introduce a water filter to the district, building one along with the ONDA members so that they could see the construction process, and building a second one to deliver to a nearby village to use for drinking water. It was very important for us to create a filter that is sustainable. This challenged us to design a filter that is not only easy to maintain, but one that could also be built again from materials entirely within the district at a feasible cost.
We began our project by researching different strategies of filtering bacteria out of water. We compared a few different ways of filtering water, including solar pasteurization, UV filtration, ceramic filtration, and BioSand filtration. After looking at the pros and cons of each, we determined BioSand filtration was the best filtration option because of its efficiency and ability to be constructed out of materials found in country. BioSand filtration is a multi-layer filtration system that consists of larger-sized gravel at the bottom with smaller-sized gravel on top of the larger gravel. Sand is filled in on top of the gravel. The top layer inside of the filter is a biolayer that forms from bacteria in the contaminated water that is poured through the filter. The bacteria layer grows over time, which increases the filter's ability to remove bacteria. There is very little maintenance required to keep the filter effective. The filter needs to be cleaned once per month to maintain the flow rate. Our initial prototype was based off of a manual created by the Center for Affordable and Water and Sanitation Technology, or COST. A PVC system was built to carry the water from the bottom of the filter to a clean water container without allowing gravel to clog the system. The outside container was built using 3 5-gallon buckets stacked on top of one another. It was decided to use a different container in country that would be made out of one piece to avoid issues with durability and sealing between multiple containers. We cut a diffuser plate out of galvanized sheet metal that was put in place above the sand and where the biolayer would form. This helps control the flow rate of the water to ensure the biolayer remains undisturbed. The prototype was built and tested in the Biological Sciences building. E. coli culture was added to tap water to simulate contaminated water, and call alert tests were used to determine how effective the prototype was. Despite a biolayer not having formed due to time constraints, it was found that the filter reduced the concentration of E. coli by over 50%.
We were in Ghana for a total of 2 weeks and had about 8 work days to complete our project. The first few days were spent shopping for materials in Kumasi and Techiman, as well as having initial meetings with members of ONDA to explain our filter design and solidify the end goals of our project. Towards the end of the first week, we began constructing our first filter. We completed it Tuesday of our second week and then began construction of our second filter. We then delivered and assembled our second filter to the Yatokram community on the Thursday before we left.
Implementing the filter in country posed many new challenges for our team. Our first step in building the BioSand filter was to find the appropriate materials in country. We sourced materials from multiple markets in Ghana, including Kumasi, Techiman, and Akumadan. We found a granite quarry in Kumasi to purchase the gravel from, found all other filter supplies in the Techiman and Akumadan markets, and had the sand for the filter donated from a construction site in Akumadan. We were able to source everything used in our filter from locally found Ghanaian stores. On New Year's Eve, we began constructing the BioSand filter with the ONDA staff. It was important to have engineers and ONDA staff present during the building process to allow education about the filter to be shared as the filter was built. On our first day of construction, we started addressing multiple components of the filter. We sent some of our group members to wash and sieve sand and gravel, while others worked with some of the ONDA staff to build the PVC system and the diffuser plate of the filter. After a long holiday weekend, the group was back to work on Sunday afternoon, washing more sand for inside the filter. On Monday, the group worked more on the filter, drilling holes in the diffuser plate and finishing up the PVC system. On Tuesday, the group worked hard to finish all of the components and began to fill the first filter with sand, gravel, and water. Unfortunately, the seal between the PVC and the bottom of the container was not perfect, and the filter leaked. The group then spent Tuesday afternoon disassembling the filter, resealing the hole with epoxy, and worked late into the night to rebuild the first filter in the ONDA annex. However, the next morning, the group discovered that the filter was still leaking. At that point in the project, it was decided that because of time constraints, the group would instruct ONDA on how to fix the first filter, but would move on to constructing the second filter to be delivered to the village of Yotokram. The second filter was constructed on Tuesday and Wednesday in the last week, with the PVC system heavily sealed with epoxy to prevent leaking. Thursday morning, the second filter was to be delivered to the village, but again, the seal between the PVC system and the container was found to leak. As a last-minute fix, the filter was taken to a plumber who melted plastic around the container to seal the PVC system. The plastic melted on the PVC seemed to seal the system when tested with water, and so it was decided that the filter would be delivered to the village that afternoon. After the second filter was finished on Thursday morning, all the internal materials and the outside container were loaded into a pickup truck and driven to the village of Yotokram. The road to the village was very eroded and full of holes, making the trip slow, long, and dusty. Upon arriving in the village, we were taken on a 10-minute walk down the side of a steep hill to the water source for the village. The water is known to be contaminated with both E. coli bacteria and Salmonella bacteria, which causes typhoid. Just from looking at the water, we noticed that it was dirty, it smelled, and it was home to many bugs. It did not look like a safe drinking source for anyone and was very unpleasant to see. We were then taken on a 15-minute walk back up the hill, carrying jerry cans full of water. We collected samples from the source water to be tested by ONDA staff at a later date, and then began constructing the filter. It was important for us to allow the villagers to have a say in the construction of the filter by allowing them to choose where the filter would be permanently located, as well as educating the people how the filter worked as it was being constructed in their village. The shape of the outside container caused multiple problems with the filter design throughout the construction phase, the first of which was the shape of the diffuser plate. Where the diffuser plate needed to be located in the filter had a wider diameter than the opening at the top of the container. Since the plate needs to be removed for maintenance, this caused an issue. The plate was redesigned to include a permanent rim that was sealed to the filter wall and had an inset disc that could be removed for maintenance. The shape of the container and the material it was made from also prevented many problems for getting a good seal between the PVC and the plastic container. An issue with the curved walls at the bottom of the filter did not allow the PVC to properly seal to the bucket. To remedy this problem, the containers were taken to a plumber who flattened out the bottom side of the container to provide a flat sealing surface. However, even with a flat side, the plastic of the bucket was not a good surface to seal to. After trying O-rings, plumber's putty, and epoxy, the team eventually got an adequate seal by melting plastic around the PVC pipe on the outside of the container.
Testing the water sources in Ghana was also part of our project. We wanted to know how contaminated the water was that we were trying to clean with our filter. We brought color plate tests with us, which allowed us to get a quantifiable concentration of bacteria in the water sources. While in country, we tested multiple water sources around Akumadon, including a well and a stream where the sand and gravel were washed. We received results from ONDA that indicated that the well water had a bacteria concentration of 69 mpn. We left ONDA with extra collo plate tests and samples of the water from the village Yatokram to continue testing.
During our 2 weeks in Ghana, we addressed all of our objectives. We were able to construct 2 filters in country. Our first filter was constructed in the OND Annex to serve as a model BioSand filter that could be replicated and used in multiple communities around the district. Though our first filter did leak, we left the ONDA staff with instructions on how to repair the filter or rebuild the filter from scratch. We were also able to construct a second BioSand filter and deliver it to the village of Yatokram. Both of our filters were constructed from materials that were found in Ghana, one of our main sustainability concerns. We were also able to create education documents and deliver them to both the ONDA staff as well as the villagers to promote the proper usage and maintenance of the BioSand filters.
The key component of our project was making sure it was sustainable in country. To make this possible, our group made sure that all materials were purchased in country and that several members of ONDA were well educated on the filter. This included sitting down with several members of ONDA like Honorable Kojo, Ficini, and Isaac, and reviewing the manual we created with them. We also had some of them help with the building of our filter. This was to ensure some of the ONDA people understood the construction of the filter. 2 manuals with detailed instructions were left behind at ONDA so that more filters could be created in the future. Implementation in the village was carefully done to also allow for sustainability. Filling the filter with the layers of gravel and sand were done with the villagers watching. A detailed description of the filter was explained to the villagers both in English and in Twi. This consisted of explaining how the filter worked, the maintenance of the filter, and the few restrictions the filter had, such as the pause period, which gives the bacterial layer at the top of the filter an hour to breathe before pouring more water through. Pamphlets were left with the villagers that describe both how to use the filter and the monthly maintenance the filter requires. While speaking with Honorable Kojo, it was decided that ownership would be addressed by assigning a few people of the village to maintain and clean the filter that was delivered. We also spoke with Kojo about designing an ONDA person to take ownership of the filter project and to help produce more filters for other villages in the future.
We spent $222 in Ghana for in-country implementation. This put us at about $50 under budget for our project. We calculated one BioSand filter would cost $77 to reproduce. We built 2 of these filters, and the rest of the $222 was spent on in-country R&D as well as startup materials such as shovels and a tarp. We encourage the engineering group traveling to Ghana next year to improve on the design of our water filter. Our largest recommendation is finding a better container, one with completely straight walls. This should remove the challenges our group faced with the leak in the connection between the PVC and the container. This will also make the diffuser plate much easier to build. It would also be helpful to plan more time for extensive testing of filters built both in the U.S. and in Ghana.
Finally, we would like to say thank you, Manasi Pa, to all those who helped make this experience possible. We would like to thank Roger and Marianne for their continuous support throughout the semester and while in country. We would like to show our gratitude to Nana for providing us with information about the culture of Ghana. We give special appreciation to Professor Pradhan of the Microbiology Department at Ohio State for providing us with access to E. coli to test our prototype and guiding us through the testing process. We thank Leslie Callahan for helping us obtain our visas and preparing us for travel to Ghana. We also give great thanks to our Ghanaian friends, Honorable Kojo, Andy, Isaac, and Ficini, for their support before and during the trip. Without all of these individuals, our project would not be possible. And with that, we sign off and look forward to hearing about future developments in Ghana through Ohio State. When in Ghana, we say, Yabisha Madamfo, or goodbye, our friends.